Hi guys, please go ahead and turn your packet to concept 20B teacher talk. So let's go ahead and look at set 1. With this one, it says we are given that angle QPS is bisected by segment PR. So angle QPS is being bisected by segment PR. And so from what we know about an angle bisector is that it cuts an angle into two congruent pieces, meaning this part is going to measure the same as this part. So those two angles will be congruent. It also, in the given, it says that side PQ, this one here, is congruent to side PS. Okay, and they want us to prove that triangle QPR is congruent to triangle SPR. Okay, so with this one, the given is already written there. Great. But we know these two triangles share a side, which is PR, this side here. So it's going to have to be congruent to itself. This side will be congruent to itself because of reflexive property. So that's actually what I'm going to go ahead and talk about in step 2. I'm going to talk about how side PR is congruent to itself, so PR, and the reason again is just reflexive property. Okay, and then step 3, here in the given it said that angle QPS is bisected by PR, and like we said, we marked it up here, but we haven't really talked about how the two angles are congruent. So that's what we'll do in step 3. Could you have flipped 2 and 3? Yeah, sure. You could have done this reflexive as your third step. Doesn't really matter. So in step 3, let's go ahead and talk about how this angle here is congruent to this one because of that angle bisector. So I'm going to say angle QPR is congruent to angle SPR. And the reason for that would be an angle bisector, or definition of an angle bisector. I'm just going to abbreviate here. Okay, and so now from this you can see that you have a side, an angle, and a side, right? Side, angle, side, the angle is included, so we're good to go. The two triangles are congruent using side, angle, side. Okay, so looking at set 2, we have this diagram here. It says given that point A is the midpoint of side JN, and also given that JK is congruent to NK. We want to go ahead, or we're asked to prove that triangle JAK is congruent to triangle NAK. So we want to show that these two triangles are congruent using one of our theorems. Before I even get to this, we can discuss some things that we can easily prove, right? We know that these two sides are already marked as congruent, but because A is the midpoint right here, we know that it's going to cut the segment into two equal pieces. So I can go ahead and conclude that this part here, AN, is congruent to this part of that segment, AJ, right? We can also see that the two triangles have a shared side, this AK. So it's shared, meaning it'll measure the same thing. So because of reflexive, it's congruent to itself. So let's talk about these two things. The given is already there. Let's go ahead and talk about, you can decide to either talk about this one here because of reflexive as your second step, or this one here because of the midpoint. It doesn't matter. So you can go ahead and flip your steps 2 and 3. That doesn't really matter. Okay? Doesn't matter which one you go with first. So I'm going to choose to talk about the midpoint. So I'm going to go ahead and talk about how side AJ is congruent with AN. And the reason for that would just be the definition of a midpoint. I'll abbreviate if that's okay. Okay. Now I'm going to go ahead and talk about AK being congruent to itself. So side AK is congruent to side AK. Reason, reflexive property of congruency. So I'm just going to write reflexive. So with that being said, you can see that you have 3 sets of sides that are congruent to 3 other sets of sides. So the 2 triangles here will be congruent. The reason will be side, side, side. Okay? All right. Now, looking at set 3. So the first question here in set 3 says, what geometric reason could be used to prove the 2 angles are congruent? So if you think back even to unit 1, we can prove that 2 angles are congruent, or we can use different theorems for those. One of them would be if the 2 angles are vertical angles, right? So vertical will be one of the reasons why your angles will be congruent. So if they're vertical angles, okay? If you have parallel lines, with that you're going to have your alternate interior, your alternate exterior, and your corresponding. So all of those 3 reasons could be used to prove angles are congruent. So I'm just going to abbreviate alternate interior angles, alternate exterior will be the other one, your corresponding, and then the last one could also be the definition of isosceles triangles, because as you guys know, if you have an isosceles triangle, then the base angles have to measure the same thing, right? So I will just say definition. I'm running out of room here, but I'll just write def of isosceles triangle. That could also be another reason. Okay. This last question here says, what geometric reason could be used to prove 2 segments are congruent? And again, even thinking back to unit 1, you can prove that 2 segments are congruent if, or you could use midpoint, right? Because that will cut a segment into 2 equal pieces. So midpoint, reflexive, right? If a side is shared, then you can use reflexive to show that 2 segments are congruent. And with this also the definition of isosceles triangle. Oops, it's just one S. This is a C, I can't spell. Isosceles triangle, because by definition, if you have an isosceles triangle, then the 2 sides, or 2 of the sides, will have to be congruent. Okay? All right, great job. This concludes this teacher talk. Thank you.